स्टार्ट करते हैं अभी. सो लेट मी शेयर माय स्क्रीन. ओके. सो आज हमारे 40 डेज बूट कैंप का डे 37 है. सो आज के क्वेश्चंस हमने लाइक पहले भी देखे थे. लाइक फ्रैक्शनल नैपसैक का प्रीवियस वर्जन लाइक 01 नैपसैक, और गैस स्टेशन का भी मतलब सर्कुलर लिंक लिस्ट जैसा एग्जांपल है. सो वो भी पहले कवर किया था, और जंप गेम का हमने फर्स्ट वन कवर किया था लाइक 2 days बैक विद डायनेमिक प्रोग्राम. सो यही तीन क्वेश्चन आज हम देखने वाले हैं. सो लेट्स स्टार्ट विद आवर फर्स्ट क्वेश्चन, दैट इज फ्रैक्शनल नैपसैक. Okay, so let's see what the question states. So, given two arrays, val and weight. So we are given with the two arrays, which are val and weight. So this represents the values and weights of items, and an integer capacity representing the maximum weight a knapsack can hold. So we have something like a sack, and we are given an array of values and weight to find the to get the integer capacity, which represent WT represents weight and val represents value. Okay, so what we need to find? So determine the maximum total value that can be achieved by putting items in the knapsack. You are allowed to break items into fractions if necessary. Return the maximum value as double, rounded to 6 decimal places. So what we are needed to return is a maximum total value that can be achieved. So this is the value array. What maximum values we can achieve by putting the maximum weight from the capacity. So the weight total combined in the knapsack should be not greater than the capacity. That's our requirement. Okay. So to solve this, first, we'll see the first we can have a brute force approach. So what we can do in a brute force approach is that we can consider every weight, every value with its corresponding weights until the capacity is maximized. Okay, so we'll compare our current weight with the capacity. If the current weight is less than the capacity, then sorry, then we'll subtract the capacity with the given current weight. Okay, so and the value will be added to it. So in this example, as we can see, take the item with value 60. So as the weight here is 10, and we have a total capacity of 50, so we can take the weight of 10, right? So once we take the weight of 10, the value becomes 60, right? Then when we take the weight 10, right? After that, we can also take value 100, as it corresponds to this one, like 20. And once we remain with 40, and once we subtract 40 from 20, we are still ahead of the capacity, and we have that required capacity to attain our weight inside our knapsack. So we'll also take this one and this one. Okay, so we can in our knapsack we can carry both of these items, and we'll take the total submission of this plus this. So it will make total of 160, right? Now there's 30. After that, there comes 30, and we have the remaining capacity of only 20. As we have already subtracted 10, then we have subtracted 20. So from 50, we have already subtracted 30. So it remains with only 20. But we have our next weight with 30 units. So how we are allowed to break the items into the fractions. So what we will do here is uh, we'll uh, we'll divide its value by the weight and what capacity that is required. So if the capacity required is we can here 30 is already done. So the capacity required is 20, right? So we'll out of this 30 weight, we'll take the 20 weight units, and corresponding to that we'll take the value of it. Okay. So if we do it, so what will be the answer? Like 120 divided by 30 into 20. So this 20 comes from the remaining capacity. This 30 is the total weight and its value. Okay. So after that we get the value as 80. So we add that value, like we had 160 before from this, and after adding 80 we get it to 40, right? But the answer is here with double, and we need to return the answer with double, and it should be rounded to six decimal place. So what we need to do is add zeros after the decimal point. Okay. So what approach we can follow to get this answer? So first, let's see the brute force approach. Okay. So first, we'll generate all the subsets that are required for to calculate all the items. So we'll have this items, right? These items with the given weight. So we'll calculate all the subsets that can be possible for corresponding to 50. So for 50, we can get like 30 plus 20. Then we can get 20, 10 plus 20 plus 20 from here. So that's also in subset. Then 10, then 20, then no any other subset can form as it satisfies the capacity. Or we can do here is we can take 30, we can take 10, and we can take 10 from 20. So what we'll do is first this 30 will minus from 50. So it will give remain 20 will remain. So we can get like 20 total. So we'll also subtract that from 10. So again 10 is remaining. So by taking the fraction from this 20, we'll take the corresponding value for it from the 100, and we'll calculate our value by adding it and rounding to its six decimal places. Okay, so that's like a brute force approach. So now, if you see the implementation of it, so first we are calling a double function find max value. If like the index and the val sizes the sizes of all the values is equal, then that's the total weight we can consider, right? So consider if the value is there's only one value in the knapsack that we can add, and there's only one weight, and the capacity is smaller than the weight. So we cannot include it, or if the capacity is greater, we can include it. So there's like an if else condition here. So if the capacity is greater, we will include it. If the capacity is less, we'll not be able to include it. So what we'll do is we'll use a ternary operator to return our total weight. So if it is less than the capacity, we'll return our total weight as the original weight mentioned. And if the capacity is less, if it is if it is greater than the total weight, will return zero. Okay, as we cannot add any other item to our knapsack. Okay, now that was our base condition. Now to include now to implement the current scenario, like here, the approach we had seen is like taking taking all possible subsets we can have, like taking 30 plus 20, taking 30 plus 20, 30 plus 10, then 10 plus 20, 20 plus 20. So our maximum capacity should be reached if the total weight is more than the given weight. Okay, so that is our base condition that we need to satisfy in order to include our current item, fractionally or completely. As it's a fractional knapsack, so you can have the item in particular parts rather than completely including it or excluding it. Okay, so that's the approach mentioned here. So that only we have done, and we have max function which will return the max from which we are including and which we are excluding. Okay, so that's our brute force approach. So what will be doing in greedy approach? So here, what we had considered first, that we'll start with the descending order. Like we'll uh, try to arrange the values in descending order so that we can get the maximum value at the starting. So if we consider like 120, so we'll need to take the weight of 30, right? So if we like arrange it in descending order, it will be 30, 30, 20, and then 10. Okay. So when we take 30, so it will make our value to 120, right? Okay, 120. Then if we take our next one, next maximum value, that is 20. So that will reach the capacity and make the value add 100 to it. So it will make 220, right? Then we'll check for other possibilities. So 30 plus 10. So what we'll get after that? So if we add 30 plus, if we add 120 plus 60 and take the take the fraction of 20, take the like 10 from 20, so we'll get is like it's the half, right? So we'll get 50. So we'll need to add 50 in that. So that will make our total to 210, which is less than the previous one. So if the value is less than the previous one, we'll update it with the max value which we keep on getting at our regular loop. So if we get a maximum value, we'll replace it with our previous value and do it until we reach our maximum value. So how we'll get to 40 is first we'll take the weight of 10, then 20. That will make our capacity to 30, and a 10 from 10 weight units from 30. So no, sorry, 20 weight units from 30. So that will make a total of 240. So 210 will be updated from 240 as we have got a new max value. Okay, so that will be implemented. Okay, so if we see the approach here, So this is a greedy approach, as we are not looking for the consequences, and we are following one consideration and sticking to it without considering any consequences which comes with it. Okay, so first what we are doing is we are creating a constructor for item, so which will calculate the ratio for each item. Okay, so consider like 10, 10 will it's like less than capacity, so like 10 will be included in it, then 20, then 30. So if we reach the maximum capacity, the ratio will be calculated as per this formula, like 120 divided by 30, the value divided by the weight multiplied by the total remaining capacity. Okay, so that will give our current item. So what we are doing is we are creating a list of items and we are storing it in an array list. With these items are created to value and weight ratio. With we get every value to its weight, and we are sorting the values according to this, according to maximum values in the descending order. Okay, so after doing this, we are comparing for each item that whether the value or the weight is within the capacity or not, and if it's not in the capacity, we are taking the fractional of it. Like if it's not in the capacity, we are taking the fractional of it, and we are breaking from the loop. If it's within the capacity, then we can already take the whole item, right? So like here, like if it's 10 which is within the capacity, so we'll take the whole item. But here, once we reach from here, so the capacity becomes 20. So we cannot take the 30 whole value. So we'll need the fraction here, right? So that will calculate our ratio. This is being calculated by the constructor we have made. So this will call the constructor and calculate the ratio from here. Okay. Now we need to round it up to our six decimal place, right? Like mentioned here, we need to round it to six decimal place. So we'll multiply and divide by 10 raised to 6. Okay. So that will make our double value too, as we need to return the double value. So that will make it to 240.00000. Okay, so that's our fractional knapsack. Can you like tell me the time complexity of greedy approach here? Like if you can see, you can type it in the chat box if you want. So as we are like traversing once only within our value range, so it will be like only n for the greedy approach. But for the brute force, it will be n square, as we need to check for each value and each weight with comparing all the capacities that are possible. But in the greedy one, as we are following this criteria to take the to sort the items first and carry out our implementation, that is when the item is within capacity, we are considering it, and when it is not in capacity, we are considering the ratio. Okay, so once we do like take the fraction of it, we need to break from there only. So like once we take the fraction, we will not be able to move forward as there won't be any other item that we can take. Okay, so that will make our time complexity to n. Okay, so have you understood? If you have like any doubt, you may ask afterwards also. Okay, so let's see our next question. That is gas station. Yeah, so that is gas station. So let's see what this question states. So there are n gas stations along a circular route where the amount of gas at the I station is gas I. So uh, we are given gas stations and like there are n number of gas stations in a circular route. Uh, so there's a circular route and there are n gas stations to it where the amount of gas at the ith station is gas I. So the amount of gas that is present at the particular station is gas a gas of I. Okay. So you have a car with an unlimited gas tank at cost of I. So there's a cost associated with the particular gas station and the gas of I that you can feel while traveling. So of gas to travel from the ith station to its next I plus one station. Okay, so you will need like gas to fill up to travel to your next station. So you can wait, either wait or you can fill up the gas or you can move forward. Okay. So what is mentioned afterwards is you begin the journey with an empty tank at one of the gas stations. Okay. So you will begin the journey. Let's consider like here it's considered from three or like any one. So you will begin the journey with an empty tank at one of the gas stations. Given two integer arrays, gas and cost, return the starting gas station's index if you can travel around the circuit once in a clockwise direction. Otherwise, return minus one. So what we are needed to find is we are needed to get the starting gas stations index if we go in the clockwise direction, and otherwise if there doesn't exist a circuit, we need to return minus one. If there exists a solution, it is guaranteed to be unique. So there won't be like gas stations with the same cost, like three with the same cost here, or four with the same cost here. So that won't be there. So you will always get a unique answer to your question. Okay, so that's already mentioned. So now we'll simulate this and see how this works. Okay, so if we start at gas station one, okay, we have to pay three costs. If we fill up three, then again we travel at two, three, four. Then we can only fill one. Okay, so we'll be able to travel only up till five. We'll not be able to reach our final goal, that is one, as we needed to travel in the circular direction. Okay, if we consider like two, then we can travel four here. So that will be applied to all the gas of I. Will need to make we will need to decide a certain path, that certain gas with the limited cost we can reach a circular path where we have started from. Okay, so if we can see the explanation here, so if we start at gas station 3 with index 3 and fill up 4 fill up 4 units of gas. Your tank is 0 plus 4, so you can travel up to 4 units. Okay, so 4 minus 1 will again fill up the tank at our fourth station, and that is with the cost of 2. So we'll minus cost of 2 from that. So that will make our cost to 7. Okay. 4 plus 5. But as we have traveled to one station, so that will minus 1. So that will make our cost to 8. Okay. Sorry, gas to 8. So after we travel from 8, we have like remaining gas as 8. Then after at the cost of 1, we after subtracting 2, we are again getting 1. At the cost of 1, we are getting, just a minute. Yeah, am I audible, right? So let's continue. Uh, so 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 once we get our value as 7, so again we'll fill up the tank after getting to gas station 3, with the cost of 2. So as we have already traveled 2 stations to reach till 3, so that will be 7 minus 3 plus 2. That will make our remaining gas to 6. Okay, so after that, once we travel after that, we'll reach to 3 with four distances traveled already, and adding 3 gas to it. So that will make our remaining gas to 5. So this as we have already reached from 3 to in a circular route to 3 again, so we can start from the route 3, from the index 3. Okay, so that is an optimal path to go to go in a circular route. So once we get a optimal path, we need to return it as there is an unique solution. So there would be any other option to travel from in a circular route, such that it minimizes the cost and gives the maximum gas availability. Okay, so that once we reach till 3, we'll return it. So that will be our brute force approach. So after doing this, what we can do to so for doing that also, as the length of the gas and cost is will be same, so we need to travel it travel this at least twice, right? So if you can see with the brute force approach, we'll need to check at every station as the starting point. So we'll need to check for this, we'll need to check for this, we'll need to check for every station possible, and we'll need to simulate it by considering all the costs that are available. So that will take our time complexity to n square. As for each starting station, this algorithm will check all stations in the circuit. So we'll need to check for this, then in a circular manner, right? So for if we are checking for three, we'll need to check for four, five, and again one, two, three. We'll need to traverse again and again to check if whether it's able to complete a circular route or not. So that makes our time complexity to n square, right? But if we do in an optimized way, like applying certain criterias, like if we do total tank what we have available. So if we like initialize total tank as gas which we currently have, and subtract the cost from it. So if we like subtract uh, total tank will remain here. That is, if we start at at the from the first index of gas of I, we'll have four. Sorry, this is for the three. We'll have it as three, as the cost is three, and we have the gas till one. Okay, so we'll again need to fill it at two. So that will calculate our total gas required to travel, and for the current tank, will will update it once we get our gas of I minus cost of I. Okay, so if current tank is less than zero, we'll update both current tank and the total tank, and if the current tank is zero, well, it's sorry, it's sorry, if the current tank is less than zero, then we'll make it zero, and the start station will update. So if we are like considering from here, then the current tank is smaller than zero, so we cannot move forward. Okay, so we need to update our station. So we'll then search for two. Then if the current tank at two becomes zero, then we'll need to check for three, right? So that in that way we'll just travel once in our gas of if we consider gas array as nums, so we'll just travel once in it. So it will be like big of n, the time complexity. Okay. So, and the space complexity becomes big of one, as we are just storing the constant space for required for all the elements. Okay, uh, that's for this question. Anyone has any doubt? Okay, so we can move to our next question. That is jump game two. Okay. So what jump game two? We had seen jump game one previously. So
डाउट एंड
there
डाउट
is,
किसी को
sorry.
डाउट है किसी को चैट बॉक्स
हाँ
में
हाँ बोल. Okay. First loop is starting from zero only. Yeah. So the starting tank will be zero only. So you will need to fill up at start station is doing how start station is doing modification. So if we are considering the all the cost associated with it, see, we are considering the cost associated with it. So we'll need to minimize the cost and we'll need to return through which starting point we are considering. So we can consider any starting point like 1, 2, 3, 4, 5. But we need to return to it in an efficient cost. Okay, so if we can return to it or we may not return to it, but the answer states that we the answer should be like you will need to return to your starting position and the cost associated with it should be minimum. Okay. So in the optimized approach, what we are doing it is we are considering the amount of total gas we which is already present in the tank. Okay. So when the tank is empty or close to empty, we are looking for the gas stations nearby it and trying to fill up the gas until we reach the circular route. And once we reach our circular route, then we can return the answer. Okay. Okay. So good to go. So this is our next question. We had seen jump game one previously, like 2 days back in dynamic programming. So there's a slight updation to it. So what we are doing here is you are given zero indexed array of integer nums of length n. Like if you had seen jump game one, so it was also the same. You are initially positioned at num 0, so we are starting from here. Each element nums of I represents the maximum length of a forward jump from index I. In other words, if you are at nums I, you can jump to any nums I plus j, where 0 is smaller than equal to j, or smaller than equal to, or is greater than equal to j, or smaller than equal to nums of I. Okay, and there's also other condition that I plus j should be less than n. Okay, and return the minimum number of jump to reach the last position. So what we need to do is we were given previously and jump game one the distance. Okay, so if we consider distance, like in one example it was given 2, so we can only travel to two positions from here, like maximum two positions. We can travel one position or two position like that. But here we are not given with any distance variable. We are only given with a nums array, and we can travel if we can jump to our next element is depends on the nums I plus j, and we have the condition for I plus j. Okay, so these two conditions we have to consider uh, while traversing the nums array. Okay, so first we'll see the brute force approach. So what we can actually do to explore all possible paths. So the brute force solution explores all possible paths to reach the last index by recursively jumping at every valid position. It calculates the minimum number of jumps by trying all combinations. Okay, so what we are doing it is uh, we are jumping from each position to its next position by checking this conditions. Okay, so if j is greater than equal to 0 and less than equal to nums of I, and I plus j is less than n. So we are checking these two conditions in our for loop, and if these conditions are true, then only we are moving forward in our nums array. If it breaks, like if you can't reach at the end, you will need to take any other possibility available. Okay, so see. Let's see our brute force implementation of a brute force approach. So first, there's a base condition that if the position is, if we are like starting from 0 and this is only our end, means if the start and end are equal, or if the start is greater than the length of the array, that cannot be possible. So the minimum number of jumps we need to take is 0, right? So if you are already standing at the destination, so you will not need to jump. So after looking that, let's jump on to our main steps. So what we are doing is we are considering two variables, max jumps and min jump. So what maximum jump you can take? That is nums of position. So first you can take to nums of 0, that is 2. Then once we update the position, then we can go to 3. Then nums of 2, that is 1. Nums of 3, that is 1. Then nums of 4, that is 4. Okay, so that will be like our max jump for the current scenario. Okay. So after taking, we are currently assigning minimum jumps to the maximum value that can be available in an integer. So for integer, so we are running the loop, considering these two conditions in mind, that j is greater than equal to 0 and smaller than equal to nums of I, and I plus j is smaller than n. Okay, these two conditions are considered, and we are making the recursive calls until we reach until the position is uh, already at the final place, and we are at each recursive call we are updating the minimum value which we get after the recursive call. So if we get like here 3, then after another recursive call, if I get 2, so I will update that, comparing that 3 with 2, I will update it to 2. Okay, so that will be our brute force approach that we'll be using. So, but as we are making the recursive calls here, so that will take our complexity to, uh, anybody can answer if you want. We are making the recursive calls here. Okay, so let me go through it once again. So, like we are jumping from one position to other position with changing the step. Like to we are jumping from 2 to 3, then 2 to 1, and this will break it, right? As we only have until 2, as we can go only 2 steps. Like this kind of example we had also seen in minimum number of rungs, which we like covered previously, like in the previous session only, with example of add minimum number of rungs. So we needed to add the minimum number of rungs to the ladder, where after adding a ladder, we can only travel that much distance. Okay, so that only we have to do here. So only we can travel at the distance of 2 plus 2 plus. So after traveling at the index 2, we can go to index 1, and from 1 to 1, then 4. That will make our minimum number of jumps to 3. Now, if I jump from 2 to 3 and from 3 to directly 4, so as there are like, as I can jump 3 steps here, so if I jump from 3 to directly 4, that will make our minimum jumps to 2, right? So you will need to update that minimum jump every time. Okay. So the time complexity would become 2 raised to n. Yeah. No, it won't be exponential. It will be 2 raised to n. We are jumping. We are jumping from a particular position to. We are making the recursive calls twice and again.
टू
Okay.
रेस टू एन एक्सपोनेंशियल फंक्शन ही होगा ना?
Yeah. हेलो सुयश, कुछ डाउट है?
वो टू रेस टू एन एक्सपोनेंशियल फंक्शन ही होगा ना?
हाँ, एक्सपोनेंशियल होगा, लाइक, but it won't be like a factorial one. Okay, exponential is right, but mentioning exponential is not the correct way. You need to mention like 2 raised to n. Okay, there are like many exponential forms. So like mentioning in an interview or mentioning in an technical round, so that would help. Okay. So we'll see the greedy approach for this. As we are traveling in this array like twice, not twice, like with in an exponential form like 2 raised to n. So we need to minimize it and need to travel it once. Okay, so what we can do here is we'll check for the farthest we can go from starting position and try to reach the end, and we'll update it once we get our minimum. Okay, so from 2 we can reach till farthest is 1. Okay, then 1 will go to here, so that will make our 3 jumps until we reach 4. So once we reach 4, that will be our that will take us 3 steps. So now we'll assign a variable which will consider this, which will consider the max we have attained till now. Okay, so we'll increment, if we'll check with the farthest we have got currently, and with will increment it with the nums of I. So after incrementing it, we'll check if it's end of our nums array, and if it's not, then we'll keep on incrementing the jumps, and the current end becomes the farthest. So if we are this, we'll update it with our farthest to, if this is our current end, this will become our farthest we have come so far. Okay, we'll also consider the next possible jumps we can take. So, like if we can go from 2 to 3 by taking only one jump, and after 3 to directly 4, taking single jump from 3 to 4, as we have three steps which we can take. So that will update our minimum counter to 2. Okay, so that will make our min to 2. Then again we again will need not be able to check, as we have already got our minimum value. Okay, so if we can say in this example, for if we take like two steps here, if we directly jump from 2 to 0, then we cannot move forward, as there won't be any other jump will be able to make. Okay, so we'll go from 2 to 3 and 3 to directly 4. We'll compare these two values, and which one is the farthest, we'll consider that, and we'll jump from that position. So for this one is the farthest, right? As it takes us three positions forward. So if we and will update our current end to the farthest. So and when the current end is updated to farthest, we'll keep on checking with the current end. If it's with our current index, then we have reached the end. So we need to return from there, and we need to check for our minimum number of jumps we have taken for that. Okay, so that's like our greedy approach. This will take the time complexity of big of n, as we are only traversing once in our array. Yeah, that's all from my side. If you have any questions, you may ask. Uh, the questions were like pretty good. This one, like gas station or jump game 2, like these are the real world type problems. So these are most frequently asked in interviews rather than the fractional knapsack or the traditional questions. So I would personally recommend you to go for such questions like gas station or jump game 2. This will also help in building your logic, and help you in your if you are pursuing for a competitive programming journey. That would help. Yeah. Okay. So anyone wants to add something? Okay. So we can end our session here. Okay, thank you for joining.